Welcome back. This is Mr. Wakefield, and we are going on into at least the first half anyway of section 1.5. There's two different parts to it, and this is going to be our first venture into word problems, otherwise known as application problems. Most word problems, you can use these 5 steps right here, including in this section. These are kind of the standard steps that you use on the typical word problem most of the time. Let's go through those real quick. And it's very important to follow these steps, especially the first 2 or 3, because if you don't, that's where a lot of times people get stuck. They kind of just try to start to throw some numbers on the page and maybe some variables and just hope it all comes together. All right, but they oftentimes will skip, for example, the first 2 steps, and they'll try to go to the 3rd step. And they don't really have a definitive plan on what they need to do. So following these steps doesn't guarantee that you're going to have everything go well. Okay, it's still going to be challenging sometimes, but that definitely does make it easier, though. And so that's good. Let's look at those first 2 steps. It says identify each quantity or quantities you're trying to find. In other words, what are they asking for in the problem? And then in number 2, it says use a variable to represent each one of those quantities. So let's take a look at the first problem. Let's find out what they're asking for, number 1, and let's use a variable to attach to that. Okay, and I'll tell you why that's important to do that here in a second. So and it says here in problem A, including 9% sales tax, you purchase a shirt for $46.57. What was the price of the shirt before the tax was added? Okay, we've all been to places before where we buy something and it'll say something on the item or maybe on the shelf that says what the price is for the item, but then when you go up to the cashier, what happens? All right, the price ends up being a little bit more than what you saw on the item or on the shelf because of sales tax, okay? And they compute that for you up at the cash register, okay? So what this is, though, or let's first of all talk about what we need to do first. We always need to do step 1 first, which is identify what you're trying to find. It says here, what was the price before the tax was added? Let's go and write that down. The price before. The key word there is before, all right, because you also have the price after the tax is added. That's the total price that you're going to end up paying, isn't it? Okay, after they add the tax to it. But this is the price before. In other words, it's the price that was on the item or on the shelf, okay, before you took it up to the cashier. I went ahead and attached a variable to it. I said that it was equal to X. You can use any letter that you want. Okay, you could use Y, you could use Z. Okay, I just picked X. And so the important thing is that you attach a variable to it, as it says here. Now, the reason why we want to do that and attach a variable is because now we're going to take that variable, we're going to put it into an equation, and then we're going to solve that equation. And as you guys now know from the last section, when you solve an equation, that means that X is going to be by itself, right? Which means that we'll then know what X is equal to. And if we know what X is equal to, we'll then know the price before the tax is added, and we've got our question answered, and that's the end of the problem. So the hardest part then is what? The hardest part is to then come up with this equation. They don't give it to you, okay? You got to find it by basically translate the words into an equation somehow. I do have some formulas that will help you, though, here in this section. Okay, let's take a look at those right now. Here they are right here. Percentage increase and percentage decrease. Let's talk about that for a minute. Percentage increase is anytime that a percentage is added to something. In other words, let me say that again. It's anytime something is added to a number by way of a percentage. For example, If your boss says, I'm going to give you a 5% raise, that's an example of a percentage increase because a raise is an increase as determined by a percentage. Okay. Another example of that, however, would be sales tax because when you go up to the cashier, they add money to the price that you have to pay, but they base it on a percentage. In this case, it's 9%. Every county in this country has its own percentage as far as sales tax. Not everybody's the same percentage. Okay, in this particular case, it's 9%. So sales tax then is an example of percentage increase, and so we can use this formula right here, okay, to help us. So let's talk about that. Here's how it works. You take the original price, and what that means is it's the price before the percentage increase is tacked on. In other words, that's in this case, that would be the price before the tax was added. Okay. You then add to that the actual percentage, which you do need to convert to a decimal. You can't just say the number 9. I'll talk about that more in a minute here. And then you multiply that by the original price again, and then that's going to be equal to the final price. Okay, so let's go through this formula, and what we want to do is we want to replace all of these words with actual numbers and variables, okay, so that we actually have an equation, okay, because as you guys know, there's no words inside of an equation, right? Okay, equations have numbers and variables and stuff like that, not words, and so we need to replace these words with numbers and variables and combinations of all that. And so let's do that. Original price. What is that in this problem? First of all, if you know the constant number that one of these things is equal to in the formula, use it, okay? If you don't know the constant number, and like for example, let me give you an example of what I mean. We know the actual number, the constant number for the final price. It says that you purchased the shirt, including the tax, for $46.87. That means that after the tax is added on, that's the final price. Okay, so $46.87 then would go here. Okay, let me transfer that down into our actual problem. $46.87 will be that number that's on the right-hand side of the equal sign, as the formula tells us. Okay, it'll go here. So if you know a constant number, you put it there. You put it in that spot. If you don't know the constant number that goes in a particular spot on the formula, but you do have a variable for it, in particular the variable, not just any variable, but the variable you designated, okay, then go ahead and use that instead. Okay, and I know that for the original price, that is X, because that is the price before the tax was added on. So that means that the X is going to go at the beginning of the problem, and then it's going to go just before the equal sign, right? Okay, I'll leave some space for that other stuff as well. Okay, so that goes in the place of the original price right here, X and X. And then we got a plus. Let me bring that down. And then as I told you guys, for the percentage, you have to convert that to a decimal. Let me tell you how to do that. Since it's 9%, let me remind you, if you don't remember this, percent means divided by 100. That's literally what the percent symbol means mathematically. And so 9% means 9 divided by 100. So if you put that into your calculator, okay, that should give you what? 9 divided by 100, okay, is going to be equal to 0.09. You could just say 0.09, same thing, okay. Anytime you have a 0 on the left of the decimal point, it's just a 0, then that's it. You don't need to write it. Okay, so 0.09 is fine, but you have to convert that to a decimal because 9%, you guys, is not the same thing as 9 by itself. So you might be wondering, well, why can't I just put 9% in the problem? It's because we never put the percentage symbol inside of an equation. It's just not something you put inside of an equation because then what do you do with it, okay? But we can deal with decimals. Decimals are just like normal constant numbers that don't have decimals, okay? We can deal with them in the same way when they're inside of equations. So that's why. All right, so convert your percents to decimals, put them in there, Now we have a legitimate equation here. This looks like a normal equation where we can get x by itself. We replaced all the words with the appropriate numbers and variables and all that. So now we need to solve this. If we go back to our previous section, section 1.4, we learned that the first thing you do when you solve an equation, at least the equations we're doing right now, is to get rid of the parentheses first. However, there aren't any parentheses where you have to distribute out any terms or anything like we did in the last section. So the next thing we do after we distribute, as we learned in the last section, was to combine like terms. I know this is kind of tougher to visualize this because of the decimal, but remember these are like terms because this is x to the first and this is x to the first. Remember the decimal, let me just give you an example of what I'm talking about. I know that decimal might be throwing some of you off because you're not used to it, and I totally understand that. But let's just pretend for a moment like the decimal, instead of it being a decimal, let's pretend it's just a normal number like 4. How would you combine like terms if this was the problem instead of this right here? When you say 1 plus 4 equal to 5x, okay, so wouldn't it make sense in the same way that just like you did 1 plus 4, you should do 1 plus 0.09? So let's go ahead and put that in our calculator. What is 1 plus 0.09? 1 plus 0.09 is 1.09. And of course the x stays the same just like it did up here because they're like terms that you're combining. Now what we have, and this makes it simpler than the last section, we don't need to do the third step of the equation solving process because we already have one single variable term and one single constant term on the other side, and that's all you have is just those two terms. So as we learned in the last section, when you have a single variable term and a single constant term, okay, step 3 is already done. You just have to do step 4. And step 4 was what? Step 4 was where you divide out the coefficient of the variable term. So don't divide by the 46 decimal, but divide by 1.09. That then cancels out the 1.09. You put that into your calculator, okay, and your answer is going to be when you divide these two decimals, okay, and make sure that when you divide for a fraction, always do the top divided by the bottom when you plug that into your calculator. Top divided by bottom. Don't go the other way. Don't say bottom divided by top. Okay, no matter what the numbers are, even if the bigger number, even if the top number is smaller, it doesn't matter. It's always top divided by bottom. Okay, when you put in your calculator and you figure out what the entire, what one number the entire fraction is equal to, which is what we're trying to do right now. What is this whole thing equal to? Okay, if you put that in your calculator, it is exactly equal to 43. Okay, there's one more thing we got to do though. It says answer the question in English. Unlike some teachers, I don't require that you write an entire sentence. I'm not asking for that. However, I do need you to do one more thing, and let me talk about that right now so that you'll understand it for all of these problems and all problems for the rest of the semester that we do for word problems. Okay. There's this thing called measurement that we have in most word problems. What is measurement? I mean, we all have an idea of what measurement is, don't get me wrong, but what exactly do I mean by that? Just so that there's no doubt that you understand what is expected of you. Okay? In most word problems, there's measurement, and what I mean by that is measurement is something that makes a number exact. Okay? For example, if I told you, if I wanted to tell you how much money I had, and I said, I have 43, you wouldn't know exactly what I was talking about, right? You would be asking yourself, does he have 43 cents? Does he have $43? Does he have 43 something else? Okay, so 43 by itself is not exact. But if I said that I have $43, now that tells you exactly how much money I have. And so for that reason, dollars is an example of measurement. Okay, cents would also be, not that we use it in this problem, but cents would also be an example of measurement, because if I told you that I had 43 cents instead of just saying I have 43, that would also be telling you exactly how much money I have. And so here's my point. When you're doing a word problem, if you see measurement anywhere in the problem, any example of measurement, and here is an example of measurement right here. Dollars, again, is an example of measurement because it tells you exactly how much money it is. Okay. Anytime you see an example measurement, okay, that typically means that the answer must have measurement in it. Okay, it's not an optional thing. You have to put the measurement in the answer if the word problem has measurement in it. And almost every word problem does. There are a few exceptions, but you won't see that here in this section. So the question is what measurement do you use? Well, what you do is you look at what you just found. What kind of thing did you just find? You just found price, right? That was the kind of thing you just found. All right, you didn't find out how many shirts they had or something like that. No. You found out the price. How is price measured in this problem? Well, we know it's measured in dollars as opposed to cents or something else because they use the dollar sign here. So we know it's price. We know price is measured in dollars. And so we know then that we need to use the dollars as our form of measurement. Okay, so one more time. Anytime your word problem has any sort of mention of measurement in it, you need to have measurement in your answer. And the way to figure out what kind of measurement you use is look at what you just found. In this case, it's price, and then figure out how that's measured. Since price is money, and since money is measured in dollars, that's how I know that it's dollars. Okay. Price is, again, anytime you're looking for price or anything that's related to money, you want to be looking for either dollars or cents in your problem. Okay. That's the idea. Next one. At a 25% off sale, now notice that's different. 25% off. That's not related to increasing something, is it? That's relating to taking money off of the price of something, isn't it? Okay, so we'll get into that more in a minute. But first of all, at a 25% off sale, you purchase a chair for $60. Okay, what was the price before the sale? Okay, there we go again. It's the exact same question as the last problem. It's the price before, in this case, before the sale instead of before the tax. But the key word there is before. Because here's the thing. Before the sale, they hadn't knocked off the 25% yet, had they? Okay, so it's the price before the percentage decrease. This is a percentage decrease instead of percentage increase because they're knocking a certain amount of money off of the price. Okay, so the price before the sale, all right, is going to be before the percentage decrease was before the percentage decrease took effect. All right, before that. All right, so that is what we're looking for. There's the variable. Again, you can use any letter you want. I used X. Now, since it's percentage decrease, good news, you guys. It's almost the same exact formula. Okay, that'll make it easier to remember. Almost the same exact formula as the first formula here. Okay. The only difference is that since it's decreased, we have a minus here in between the percentage and the original price instead of a plus like we had up here. Everything else is exactly the same. So, once again, do we know what any of these things are as a constant number? Not a variable, but as just a normal constant number. Do we know either the final price or the original price? Okay, we know the percentage, and we'll convert that to a decimal in a minute. But do we know either the original price or final price? Yes, we do. We know that the final price here is $60. How do I know that again? How do I know that the $60 isn't the original price? It's because it says you purchase it for $60. That means that you that's the final price that you're going to have, as opposed to the price before they knocked off 25%. Okay, so they wouldn't say purchase if it was beforehand because they've got to knock off the 25% before you can purchase it, right? So the 60%'s got to be the final amount. So I'm going to put the 60 The $60, excuse me. The $60 is the final amount. And so that's the final price. It goes on the right-hand side just like it did in the previous formula, the previous problem. We don't know what the original price is, but just like the last problem, it's the X because that's what we designated it to be. Okay, so again, if you don't know something, in this case the original price, but you do have a variable designated for it, then you put the variable in that same spot here, and I'll do that. X in that first spot and then X just before the equal sign, just like the formula tells us to here. Then you bring down your minus sign. Since it's a decreased problem, we're going to put that minus sign right there, just like the formula says up here. All right. And then just like the formula also says, we need to convert the percentage to a decimal. Okay, again, the percent, just like in the last formula, last problem, we put that just before the original price when it happens again right here the second time. So what is 25% off? If we convert that to a decimal, that's going to be 25 divided by 100. If you put that in your calculator right now, 25 divided by 100, you will get 0.25. Same thing as 0.25. You can write it either way. 0.25 or just 0.25. All right. So that, again, is a legitimate equation where we got rid of all of the words, just like I did in this one over here. Got rid of all of the words, replaced them with variables and numbers and all that. Now we can solve the equation to figure out the answer because, remember, x represents the answer. And so if we solve the equation, we're going to solve for x. Once again, just like in the last problem, there's no parentheses to distribute out. But there are like terms to combine. Since these are like terms, what do? We say 1 minus 0.25. Go ahead and put that into your calculator, 1 minus 0.25. And what you're going to end up getting is 0.75. You could say 0.75, same thing. But the x stays the same, right, since we combine like terms. Okay. And just like the last problem, after you do that step, we have just a single variable term and a single constant term. Remember, you can't go to that last step where you divide out unless only one side's allowed to have the variable. If both sides have a variable, then you got to move them to the same side. Remember, all the x terms have to be on one side. All the terms that don't have a variable in it have to be on the other. That's what we learned in section 1.4. Okay. So since we have one side with a single variable term and one side with a single constant term, we are now ready to divide out. Okay. Those cancel. And what does your calculator say when you type in 60 divided by 0.75? Again, put it in there in that order, top first and then bottom. What it should say is 80. 80 what though? Well, just like the last problem. Okay, we know that there's measurement in this problem because they mentioned dollars. Okay, is that the measurement? Or is it the number of chairs, for example? That could be a possibility as well. Okay, the number of chairs, that's a measurement because if I said that I bought 3, instead of saying I bought 3 chairs, okay, then 3 chairs would be exact and 3 would not be. Okay, you wouldn't know what I was buying if I just said I bought 3. Okay, but if I said I bought 3 chairs, then you would know exactly what I bought. So chairs would be in a measurement as well. Why is it that the answer is not 80 chairs? Okay, it's because X represents what? It represents price. Price is money. It's not chairs, right? It's money. And we know that money in this problem is measured with dollars again. Okay, usually money is going to be measured in dollars or cents, okay? Because these problems were made by somebody who lives in the United States originally, okay? I didn't make most of these problems. I made some of them, but because of that, you're going to see dollars and cents usually. Okay, so because of all that, because it's price and because price is because price is a type of money, and because of the fact that money is measured in dollars in this problem, as we see right here, and not cents, that's why we know that the 80 means $80, not 80 chairs or 80 something else. Okay, so that's a good starting point here for our understanding of how to do word problems. Every word problem is different though, but we'll go through each one carefully as we go throughout the semester as we see different types of word problems. For now though, since these are numbered problems, I'd like you to try these right now. Go ahead and give them a try. Hit the pause on the video, and then when you hit play again, just like it did in the last section, I will then show you the answers. Okay, let's take a look at number one right here. Number one is very similar to problem A because it talks about sales tax. Once again, the question is what's the price beforehand, just like it was in problem A. The difference, though, is that this time the final price is $226.80. Okay, and so that will go into the last position over here. All right. Again, let me not go too fast here, though. Let me mention again, not that this is a surprise after we did the problem A, but we attach an X to the price before the tax is added because that's the question they asked us, right? It says find the TV's cost before the tax is added. Okay. Price, cost, same thing. And so we end up with a very similar situation where our percentage is 8%, so that converts to 0.08, 8 divided by 100. You put the X's in the same spot because it represents the same thing that it did up here in the previous problem. And then the final price. How do I know again that that's the final price right there and not the original price? Okay, because if it was the original price, we'd have to put it over here, wouldn't we? Where the X's are. No, it's the final price because it says including the sales tax. So they're trying to tell you that it's after they've already tacked on the sales tax to your total charges. Okay, so it goes there. Let's now solve this equation. We solve it by what? Just like before, we don't have to do any distributing because there's no parentheses. So we combine like terms. We then have to divide out because we already have a single variable term and a single constant term on separate sides. So step 3 of the solving process that we learned in 1.4 does not need to be done, where you move the variables to one side and the constants to the other. But so now we just divide out. If we divide out, we get X by itself, and it's exactly equal to 210. Again, 210 is X. X represents the price, which is a type of money measurement. And so therefore, dollars, because dollars is how we measure money in this problem, that is since that's how they measure money, the final answer is not just going to be 210, it's going to be $210. So again, you can't get full credit on a problem, you guys, unless you remember to put the measurement on there when a word problem has measurement in it. So don't forget that, okay? Problem number 2. After a 30% reduction, remember a reduction is just like a sale, just like it's the wording is a little bit different than problem B, but it's a similar thing where they reduce the price by a percentage of 30%. Just like in problem B, they reduce the price by a percentage of 25%. Okay, now notice it also says you purchase a dictionary for $30.80. Okay. Notice they said you purchased it for that amount. That means that that's the final cost walking out of the door of the store. Okay, and so therefore, we are going to end up with $30.80 as our final price. Okay, and that would not be the original price. Once again, though, just like in the previous problem, like all 4 of these problems, the X is the price before this percentage decrease takes place, or percentage increase in some of these problems. Okay, and it's pretty easy to see that too because it says before, right? It's the price before, so it's easy to pick up on this time. So we put the X's in the same normal place. We put our percentage where it's supposed to go, where you'd say 30 divided by 100. It's equal to 0.30 on your calculator. Don't forget that it's minus because it's a reduction or a sale. That means that they're knocking money off of the original price, and so you got to say minus instead of plus. Okay, so sales tax, you got to use the plus. A sale, like if they're having a 25% off sale or 40% off sale, something like that, or if they say that they're reducing it by a certain percentage, which also means the same thing as having a sale, okay, that's when you do minus, okay, because that's a percentage decrease. I just want to make sure you remember the difference there between plus and minus. So we then solve this equation. We combine like terms, very similar to the previous three problems. We then divide out for the same reasons as before, okay? And what's our final answer there for x anyway? And we'll put the measurement on it after that. It is going to be 44. 44 what? Well, for the same reason as in the other three problems, okay, it's going to be dollars. And so our final answer is not just 44, it is $44. Okay? So that concludes the first half of section 1.5. I'll have a separate video for the second half. And so look out for that. But in the meantime, as usual, message me or see me in my office hours if you have any questions. Have a good day.